The second method that we're going to take a look at today is called the box method. It probably looks very familiar to you, to the ladder method that you use. Some of you probably chose to use for prime factorization, and it works very similarly, except now we've got these double rows, so that's why I call it the box method. So the way this works is it's like reverse division, just like you had for prime factorization, where you have to divide out, but you have to divide what's in common. So I see between 6 and 8 that I can divide out a 2, if I can get this to right, there you go. And then I say, well, 6 divided by 2 is 3, and 8 divided by 2 is 4. And when I look here, 3 and 4, they don't have anything in common anymore, so then that means that my GCF is what goes straight down this column here, therefore my GCF is 2. Now when it comes to my LCM, I like to say it's the L. So we go down and over, and what we do here is we do multiplication. So it's multiplying here and here. So you take 2 times 3 times 4, which 2 times 3 is 6, 6 times 4 is 24. Looking at the next example of 10 and 50, I see that I can divide out from 10 and 50, I can divide out a 2, which leaves me 10 divided by 2 is 5, 50 divided by 2 is 25. Now some of you might be saying, well, what if I can divide something bigger out that's not necessarily prime? I guess that's okay, but I'd prefer if you start with the smallest prime and work your way up, because it'll make your life easier, especially if you struggle with division. So then I say, well, 5 and 25, I know they can't be divided by 2 and they can't be divided by 3, but they can be divided by 5. 5 divided by 5 is 1, 25 divided by 5 is 5. If you ever get a 1 in the bottom, you should know that you are done. So then we've got 2 times 5 down the column, which is our GCF, which means our GCF is 10. And then down the L, we have 2 times 5 times 1 times 5. 2 times 5 is 10, 10 times 1 is 10, 10 times 5 is 50. And I'll write down here that we took 2 times 5 times 1 times 5.